Good morning, everyone. Today's Wednesday, and we're going to talk a little bit about how we're going to change energy from a natural resource into an energy that we can actually use. Yesterday we said that, there's all these natural resources, like let's say running water, but you can't use running water to, say, power your iPad. And sunlight. The sunlight is great. But you can't really use sunlight in most cases to power your computer or to help you drive your car. And let's take coal, for example. Coal is great, but a lump of coal or some oil or a fossil fuel is not going to heat your house directly. And so therefore, we are going to have to change the energy in the natural resource into electricity that we can use every single day. And how do we do that? Power plants. It's like this. Let's see if I can. A power plant is used and it takes a natural resource, maybe it's oil, maybe it's coal, maybe it's sunlight, maybe it's water, maybe it's plants, maybe it's uranium, whatever it may be. And it puts it into a power plant. And out of that power plant comes electricity. And electricity is what we can use every day to power our devices and our houses and things of that nature. So what you have to do is you take this natural resource, and all of these different things, all of these natural resources have energy in them. Oil has chemical energy and potential energy. Plants have potential and chemical energy. Coal has potential and chemical energy. Uranium has potential and nuclear energy. Sunlight has thermal and radiant energy. Running water has kinetic energy. All of these things have energy, but we can't use that energy directly. We need to put that energy into a power plant and change it into electricity. Now, what do we know changes energy, everyone? The LOCE. And so basically what happens in a power plant is that it takes the energy of a natural resource and it transfers it into electrical energy using the law of conservation of energy. And that is very important. And everyone, power plants get a really bad rap, these days, but they are necessary. Power plants are necessary to give us electricity, all right, to change the energy of a natural resource into electricity. And we're going to talk about all the different types of power plants. But what do you need to know that's most important? Let's see if I can find it again. All right. So, how does a power plant work? Well, obviously, as we said, it's going to take the energy from a natural resource from Earth, and it's going to use it to spin what is called a turbine and a generator. And that's really the most important thing. All right, let me see. I can't write on this, unfortunately, because it's not in the... All right, you're just going to have to bear with me. All right, there's two main parts of a power plant. You know what? Let's see if I can. There's two main parts of a power plant, and one is a turbine, and the other is a generator. Now, it doesn't matter what kind of power plant you have. They all have a turbine and they all have a generator. They are the most important parts. Now, what is each part? Well, a turbine is nothing more than a fan. That's it. It's a stinking fan. It has blades just like a fan. It turns like a fan. And that's what it does. It spins. Now, the turbine is connected by like a wire or a chain or something. And when it spins around, it's connected to the generator, and that works the generator. Now, what is a generator? This is very important. This is made up of a magnet and a coil. And when the turbine spins, because it's a fan, that's what it does, it begins to move the generator. And the magnet and the coil begin spinning as well because it's connected to the fan that's spinning. And it creates electrons and electrical current, and that can be sent to your home, to your school, or whatever it may be. So the fan's got to move. The fan moves the generator makes electricity. So the question is, how are we going to move the fan? And that's the big question. How are we going to move the fan? Well, maybe you put this turbine in some running water, and the running kinetic energy of the water turns the turbine. The turbine then connects to the generator and moves the generator, and out comes electricity. Maybe we want to put this turbine in the sky, and the wind, in a windmill, and the wind will push it. And the wind pushes it and turns the turbine, which works the generator, which creates electricity. But what happens if you're not around running water? And what happens if you're not around the air or a windy place? Well, then you need this. You need a boiler. And the boiler is just a big bathtub of water. That's it. It's a big bathtub of water. And so what do you do with water? You heat it up. Now you can heat the water by breaking uranium. If you break uranium, it creates so much heat that it can heat up that boiler, the water in the boiler. Or maybe you burn some fossil fuels, such as oil, coal, or natural gases. These are ways, or maybe you burn wood or plants. But if you have a heat source to work to heat the boiler up, and then the boiler begins to boil. The water begins to boil, and what does it turn into? Yep, you said it, steam. And steam is fake air. You can put it under pressure, and then the steam flows out and can turn the turbine. And that's basically another way that you can turn the turbine. Now, getting back to our drawing, think about the boiler as a tea kettle. Okay? You heat the tea kettle up. The water inside starts to boil. And eventually, it starts to whistle. Why? It starts to whistle because the steam is coming up and it shoots out. The steam shoots out of the tea kettle. Well, if you had a fan right there, or a turbine, it's a crappy drawing, I'm sorry. If you had a turbine right there, or a fan right there, that steam would turn it. And that's exactly what happens with a boiler. It's like a giant tea kettle with a flame underneath. But you gotta figure a way to heat up a lot of water, and for that reason, you need natural resources. So basically, that's the way in which these power plants work. You need a turbine, you need a generator. If you can spin the turbine using a natural resource, awesome. That totally takes out a step, because the turbine will then turn the generator, and the generator will shoot out electricity. But if there is no water and there is no air, then you're going to have to get a boiler and a heat source. All right. Now, what I want to do is I want to show you guys a mini generator that I have at my house. What's up, everyone? All right, let's see if I can get this thing working. Let's try to set this up so you can see it. Okay, this right here is a mini power plant. Okay, as you see right here, this represents your turbine. It's not a fan, but it spins like a turbine. But it uses my kinetic energy in order to spin it. This is the generator. It's made up of a magnet, north and south magnet, and a coil right there. And it's connected. The turbine is connected to the generator. And so therefore, when you spin one, the other begins to spin. So you spin the turbine and the generator moves. Now, the generator is connected by wires to a light bulb. This would be your house or our school. And so if I spin it fast enough, I should be able to light up that light. So let's see if I can do it. I'm going to turn the lights off. Ooh, dark. Here we go. There you go. I'm spinning the turbine. It's connected to the generator, and that lights up our schools and our houses and everything else. And that is basically how a power plant works. This is a mini power plant. All right, so you have your turbine, you have your generator. They are connected. When you spin the turbine, the generator moves and produces the electricity. Now, once again, this is the law of conservation of energy. My kinetic energy spins the turbine. The kinetic energy of the turbine spins the generator, which is potential energy right now, and that changes it to electrical or kinetic and electrical energy, which then goes through the wires. The electric energy is then changed to radiant energy of the light. This is the law of conservation of energy, and it's how a power plant works. All right, it's all about spinning this turbine. How are we going to spin it? We need a natural resource. We'll talk about that in a little bit. Thanks, guys.